What is the purpose of scientific notation? What is scientific notation? Well, here we'll be learning about parts of the scientific notation, the reason why we need to use scientific notation, how we convert scientific notation to standard number or standard form, right? So, first of all, let's introduce scientific notation. Scientific notation is simply to measure large distances or small distances or small things. For example, the virus. A virus is so small, like that of the COVID-19, that is very, very small. It can't be seen, so therefore we need to measure it. So this is what we use, the scientific notation, as well as the distance, or the distance around the planet Earth, or from one end of the Earth to the next side. Or we have our galaxy. Our galaxy from one point to another point, that's a very far distance. Okay, so we don't have pictures for this ones here, but just keep that in mind. The main idea here is to measure large distances or small distances. So scientific notation is to measure large or small measurements, and I'm going to use the word measurements because that may be small value or um, small masses. All right, if I just put distances, I don't want it to stay restrained at only distance we can measure with scientific notation. So the main idea here is for us to measure anything that is very large or anything that is too small. So let's start by defining it. So we will define scientific notation. Define. Well, it is a way for us to write, okay, or we can say that it's the product of a number between 1, including 1, and 10, denoted by the letter n. So let's see how this works. We have a number. I'm going to give you some examples, and then we're going to take our definition from that. So consider a number as 5.7 times 10 to the 6th power. What does that mean? All right. Or another number as to say 8.62 times 10 to the negative 6th power. All right. Or we may have say 7.689 times 10 to the 20th power. What does all that mean? Well, notice that we have numbers here with decimals also. We have a base to a power, but this power is negative. Nothing is wrong with that. Okay, so the way we're going to define our scientific notation, by definition, we can say it is written written this thing here is a product, as a product of a number. Okay, which number? This is the number between 1 inclusive, which means include 1, and 10. Okay, denoted by n, right? And an integer power of 10, denoted by small n. In symbols, okay, scientific notation has the form n times 10 to the n power. Let me put it here. N times 10 to the small n power. Now let's understand our definition good. But this is saying that for us to write scientific notation, this n here is a number between 1 and 10. 1 inclusively does not include 10. Alright, so it goes up to 10. Now apart from that, this is a product, which means times a base 10 to an integer power, which means it can be positive or negative. All right, that's what this scientific notation means. All right, but remember, it's an integer for this part here. Right, so let's see the decimal part. So this piece here is the decimal between 1 and 10. That's the decimal part. Okay, and this one here is the integer exponent. The n is the integer exponent. Okay, so that's what we mean by the definition of scientific notation. So remember, it is simply the product of a number between 1 and 10, and it has a base with a power, which is an integer exponent. Now keep in mind how we have these numbers. Notice that there's only one number on the left hand side of the decimal point. There are more than one number on the right hand side of the decimal point, and there means at times. Alright, so if you're struggling to get a time, the multiplication symbol, you can use asterisk for the meantime.